Hi to all. Today we see a paper titled Simulation as an Engine of a Physical Scene Understanding from the Department of Brain and Cognitive Science, Massachusetts Institute of Technology, Cambridge. So what this paper says about whenever a human see some scene similar to figure A, like this scene is something like a workshop. We not only see what are the objects present inside these workshops, we also know that what will happen when the tabletop is removed, the objects will fall down, or when the tabletop is slide on one side, the objects will be sliding on the other side, and the tire resting on one of the legs of the table will be fall down if the table is moved, and so many objects are hanging on the hooks can be removed very clearly by helping with the hands. So how do these things can be understood by the human beings? How these physical scenes understandings linking the perception with higher cognitions? So this is a very critical to the origin of intelligence. So despite this importance of these physical inferences, the computational mechanism underlying this in our mind and human brain remain unknown. So one of the earlier studies says is there should be some intuitive physics systems inside our human brain that would be activated to understand this physical scene and make some physical inferences. But earlier studies shows that those intuitive physics would not be based on Newtonian mechanics. But later several studies have revealed that there should be some kind of a noisy Newtonian framework behind this intuitive physics running inside our human brain to make these physical inferences. So the goal here in this paper is to develop and test a computational framework for intuitive physical inference appropriate for the challenges and affordances of everyday scene understandings. The first and foremost work related to this proposal was articulated by Kenneth Greig, and that says about that brain builds some mental models that support these physical inferences by doing some mental simulations analogous to how some kind of graphical simulations are being done for prediction and manipulation of complex physical systems. These runnable mental models has to be invoked inside our brain to understand this high level physical and mechanical understanding. And these systems, these kind of mental models have severally implemented in computationally in classical artificial intelligence systems. So similar to these ideas, this paper proposed that there should be some probabilistic Bayesian cognitive models running inside our brain to understand these physical inferences and to quantifiably explain the physical scene understandings. So this paper focus and support inferences about configurations of many rigid body objects subject to gravity and frictions based on these intuitive physics engines. So the architecture of this physics engine, before we know about the architecture of this physics engine, so the first and foremost essential for these mental models to work is to capture the scene of the physical scene. For example, figure 1A, that has to be captured somewhere related to some kind of a graphical or some kind of geometrical models underlying the computer aided CAD programs. So this is the foremost input to those simulative model running inside our human brain. So there are three foremost criteria for this intuitive physics engine characteristics. One, it is based on simulation, not similar to the analytical models. So these nonlinear models runs through several time steps to understand and predict and make the forecast about what are the objects behind that. The second one is, it is a probabilistic one, not a deterministic ones. So it runs so many simulation and try to make an inference about what are the possible occurrings based on the noisy non-Newtonian models. And third one is inherently approximate. So there should be some trade-off between a computational and the accuracy. So we are making a fast inference as a human, so it has to be inherently very approximate and not computationally intensive models. And the central claim, again this paper says, is that human capacity for physical understanding and how people make rich inferences in a diverse range of everyday settings, including many that have not been formally studied, is through these probabilistic simulations. For example, if we take into figure 1c, we, on seeing that, human can easily understand what are how this scene is very unstable and small perturbations can make these cup and saucers to fall in any directions, and it not only will make the human to understand that will be fallen, but it also make to human that how far it will fallen and which directions it will be fallen. So these understandings can happen only through some kind of an physical models running inside our human brain, not to make this rich physics understandings. So there are so many experiments done from this paper, and all those experiments have some inferences from the human beings, and those inferences are coinciding with the output of the simulation models. So what are the other directions we can go for these physical inferences? What are the other models this this thing can support? Is one thing that we can go for is model free data driven approaches, but these model free data driven approaches have some price for that, which depends heavily on learning from past experience, either by memorizing very large data sets of examples or by training a combination of very rich image feature to predict the judgments of the interest. So these have so many limitations, and it cannot be possible for several some of those limitations are it needs a wide area of rich data sets, and this and moreover these models are not very compact enough to be learned from the people's finite data sets. So the choice would be is the model base, which is very more flexible and general purpose and does not require substantial learning time and learning memory. So more broadly, what this work says about is very unique directions for connecting people's understanding of physical scenes with other aspects of cognitions. Probability simulations may explain how physical knowledge influences perceived scene layouts. So the other paper that they have published is similar to that, but it's more this paper is more targeted to about how we human understand about the rigid body motions. The next paper mostly it would be like how we also human can understand, our human brain understand how the fluid motions can happen. And that also says that there should be some intuitive fluid model should be running inside our brain, similar to what I explained earlier, that law of conservations. So that's all for today. Hope we see in the next lecture about the intuitive fluid physics inside running in our human brain to understand the physical inferences. Thank you.